Hello dear children of class 7 and welcome back. Dear children, in previous video we covered thermal expansion in solids. Today we will be covering about thermal expansion in liquids and gases. Okay, now we learned last time, in the previous video, that thermal expansion in solids is the least. Why? Because the particles are very tightly packed together. But in case of liquids, in case of liquids, the particles are already loosely packed. Okay, particles are already loosely packed. So thermal expansion in liquids is greater than that of solids because particles already have gap. They don't need extra energy to push other particles away. They already have the gap, they can easily shift. But here's the fun part, dear children. In previous classes you might have learned that in liquids, there is fixed volume but no fixed shape. Liquids don't have a fixed shape, they have a fixed volume. So only volume expansion counts. Only volume expansion counts. The practical application of liquid expansion is the use of mercury thermometers. You see, in a mercury thermometer, the mercury controlled link moves up only when it is exposed to heat. Why? Because the mercury heats up and it starts moving upward. It starts expanding and moves the marker along with it. Alright. Now, when it comes to gases, thermal expansion is the most. Why? Because the intermolecular space in gases is more than that of liquid or solid. In fact, it has the most intermolecular space, so the expansion in gas also is the most. So gases, when exposed to heat, they expand very fast, same like liquid. They expand in relation to volume, right? But they do it very fast. If you can try this with a very simple experiment. Take a metal bottle, and fix up a deflated balloon over it. Deflated means a balloon which is not filled with air. Simply fix up a balloon. Now take a pot full of boiling water. Take a pot full of boiling water and place the metal bottle in the pot. What you'll see? You'll see that the balloon will start blowing up. Balloon will start expanding. And why this happens? Because of the simple reason of thermal expansion. You see, heat from the water will heat up the metal bottle, which in turn will heat up the air inside it. Air, once it's heated, it becomes lighter. It will rise up and make the balloon inflate. It will inflate the balloon, or it will make the balloon blow up. So a simple experiment to show you expansion of gases. Now in the same way, dear children, there is one more experiment. It's a metal ball experiment. Now take up a stand. Let there be a ring here. Take a metal ball. Take a metal ball which is equal in size to the circumference of the ring and put it. Now start heating the ring below. As the ring will be heated, the ring will expand. Becoming bigger in circumference than that of the metal ball, and metal ball will slide down. After the heat is supplied, the metal ball will simply slide down. Why? The ring will expand. The ring will expand. Same kind of experiment you can also do with a bimetallic strip. If you remember from the previous video, a bimetallic strip is a combination of two different metal strip. So when different metals, when two different metal strips, they are supplied with heat, okay, they will expand, but due to different expansion attributes, okay, as they expand differently because they are two different metals, they will not expand together. Instead they will bend. Because both will be supplied with heat, both will start expanding, but one might expand faster than another, which will lead to bending of the strip, like I taught you in the real application of the bimetallic strip on thermal expansion of solid. So you see, different solids expand differently. Okay, what we can conclude from here is that different solids expand differently when they are exposed to same amount of heat. Okay, even if you keep the temperature, even if you keep the temperature constant for both, they will expand differently. Now dear children, with this I end this short video. In the next video we will be learning about the ways the heat moves from one body to another. Okay, for the timing you will go through the thermal expansion in solids, and you will learn about bimetallic strip and invar, as well as the experiments which I taught you here. Thank you very much. Stay safe.